Before there was memory, before there was life, before even the idea of survival, there was silence. Not the silence we know, not the absence of sound in a quiet room, but a deeper, older stillness. A silence without ears to hear it. A silence stretched across space and time, unbroken, unobserved, and infinite. In that silence, the earth did not yet exist. There was only dust drifting slowly through the darkness. Tiny fragments of ancient stars, scattered by explosions so old that even time had not learned how to measure them yet. These particles moved without intention, pulled gently by gravity, gathering little by little over spans of time so long they feel almost unreal to the human mind. Millions of years passed, then tens of millions more. Nothing hurried, nothing needed to. Slowly, almost imperceptibly, the dust began to collect. Small pieces met other small pieces. Pebbles became stones. Stones became boulders, and with every collision, with every quiet merging, gravity grew stronger. What had once been a loose cloud of debris began to form a body, a growing presence in the dark. This was not yet a planet. It was unfinished, unstable, violent in a way that only newborn worlds can be. As the mass grew, so did the impacts. Rocks the size of mountains slammed into one another at unimaginable speeds. Each collision released vast amounts of energy, heat blooming outward like silent explosions in space. There was no fire yet, only molten stone, glowing briefly before cooling again, only to be shattered once more by the next impact. Over time, the growing earth became a world of constant catastrophe. There was no surface to stand on, no sky above, no ocean below. The entire planet was a churning sphere of molten rock, its interior heated by endless impacts and the crushing pressure of its own weight. For millions of years, the Earth was nothing but disaster. Asteroids fell without warning, planetoids collided head-on. Each impact reshaped the planet, erasing whatever fragile structure had begun to form before. The crust cracked and reformed again and again. Mountains rose and vanished in moments. Seas of magma rolled across the surface, glowing dimly in the darkness of space. This was the first age of catastrophe, though no one was there to name it. Time passed. Slowly, the rate of impacts began to change. The solar system, once crowded with debris, started to settle. Fewer objects crossed Earth's path. The violence did not stop, but it softened, stretched out, allowing moments of relative calm between collisions. And in those moments, the planet began to change. The surface cooled just enough for thin plates of solid rock to form. They floated briefly atop the molten interior like fragile ice on a boiling sea. Cracks spread through them. They broke apart, sank, and were replaced by new crust rising from below. Above the surface, something else was beginning to take shape. Gases trapped deep within the earth escaped through countless volcanic vents. They leaked slowly at first, then in vast, choking plumes. Steam, carbon dioxide, nitrogen, sulfur. Poisonous clouds that wrapped themselves around the planet, clinging to it, held in place by gravity. This was the birth of the atmosphere, but it was nothing like the sky we know today. There was no oxygen, no blue, no clouds drifting gently overhead. The air was thick, toxic, and hot, filled with volcanic ash and chemical storms. Lightning cracked constantly across the darkened sky, illuminating the surface in brief, violent flashes. Still, the planet was changing. As the surface cooled further, the steam in the atmosphere began to condense. Tiny droplets formed high above the ground, gathering slowly, growing heavier with time. Eventually they fell. The rain began, not gentle rain, not passing showers. This was rainfall on a scale the modern world has never seen. For thousands of years, perhaps millions, the rain poured down without pause. Water struck the hot rock and hissed into steam. Then slowly, as the surface cooled more and more, the water remained. Oceans were born, they filled low places in the crust. They spread outward, covering vast regions of the planet. They absorbed heat, calming the violent temperature swings of the early Earth. The surface grew more stable. The storms above continued, but something new had arrived: persistence. For the first time, the planet could remember itself, but catastrophe was far from over. Not long after the oceans formed, the Earth experienced one of the most profound disasters in its history, a collision so immense that it would permanently alter the planet's future. A massive body, perhaps the size of a small planet, crossed Earth's orbit. It did not miss. The impact was absolute. The collision released more energy than any event since the planet's formation. Entire sections of Earth's surface were vaporized instantly. Molten rock was flung into space in enormous arcs, forming a glowing ring of debris around the planet. From this debris, slowly over time, the moon was born, but the cost was immense. The impact reheated the planet almost entirely. Oceans boiled. The fragile crust was shattered. Whatever stability Earth had begun to achieve was erased in a single moment. The atmosphere thickened with vaporized rock and ash. The sky glowed red for centuries. This was not an ending, it was a reset. And once again, the planet was forced to begin anew. Time passed, patient and indifferent. As the debris cleared, Earth cooled once more. The oceans returned, condensing from the thickened atmosphere. The crust stabilized again, stronger this time, shaped by what it had endured before. Volcanoes continued to erupt, but more rhythmically now. Tectonic plates began to move in slow, deliberate patterns. The planet was no longer a constant explosion. It had entered a long, uneasy balance between destruction and creation. Yet even in this calmer age, catastrophe lingered. The young sun burned more violently than it does today. Powerful solar winds swept across the inner solar system, stripping atmospheres from smaller worlds. Mars lost much of its air. Venus was transformed into a furnace. Earth, too, was threatened. For a time, it is possible that much of Earth's early atmosphere was torn away by these relentless solar storms. Gases escaped into space, thinning the sky, exposing the surface to radiation and vacuum. Again, it seemed as though the planet might fail, but deep within the Earth, forces continued to work quietly. Volcanic activity replenished what was lost. Gases rose again from the mantle. The atmosphere rebuilt itself, layer by layer, thick enough to protect the surface, dense enough to hold heat, strong enough to endure. By chance or by resilience, Earth survived. And then slowly, quietly, something extraordinary began to happen. Within the vast, dark oceans, chemistry took on new patterns. Simple molecules drifted together, broken apart by heat and lightning, only to reform in new combinations. Energy flowed through the water, through mineral-rich vents on the ocean floor, through cracks in the planet's crust. There was no intention, no design, only time. And time, given enough space, can create almost anything. The first fragile systems appeared, not life as we know it, but something closer to a beginning. Self-replicating molecules, chemical cycles that persisted instead of fading away. Structures that endured long enough to change. Still, catastrophe hovered overhead. Asteroids continued to fall, though less frequently now. Each impact stirred the oceans, heated the surface, and threatened to erase these early experiments in complexity. For millions of years, creation and destruction danced together, neither gaining a lasting advantage. Many beginnings were lost. Again and again, progress was undone. Yet with every reset, something survived, something adapted, something learned not consciously but through persistence. Eventually, the planet crossed a threshold. Life, simple, microscopic, and fragile, took hold. It did not spread quickly. It did not dominate. For an unimaginably long time, life remained quiet, hidden beneath the waves, altering the planet so slowly that the changes were almost invisible. But the presence of life introduced a new kind of catastrophe, one that would reshape Earth more completely than any impact or eruption before it. As these early organisms lived and reproduced, they released a waste product into the oceans and the atmosphere: oxygen. At first, this oxygen reacted immediately with the environment. It rusted iron dissolved in the seas. It vanished into chemical bonds unseen and unnoticed. But slowly, over hundreds of millions of years, it accumulated, and when it did, it changed everything. For many forms of early life, oxygen was poison. The atmosphere transformed from a protective blanket into a deadly force. Countless organisms died. Entire ecosystems collapsed. This was one of the first mass extinctions in Earth's history, quiet, invisible, and total. The sky itself changed color. Methane-rich air gave way to oxygenated blue. Temperatures shifted. The planet cooled. Ice began to creep outward from the poles. Earth was entering another catastrophe. A frozen world awaited. And that is where this part of the story must pause, at the edge of a planet on the verge of freezing over completely, carrying life with it into the ice. The cold did not arrive all at once. It came quietly, almost politely, spreading its influence over millions of years. The oceans, once warm and restless, began to lose their heat. The air grew thinner, clearer, sharper. Ice formed at the poles first, delicate and seasonal, advancing and retreating with slow, ancient rhythms. At first, nothing seemed wrong. Life continued its quiet work beneath the surface of the seas. Microbial mats spread across shallow waters. Chemical cycles repeated themselves endlessly. The planet appeared stable, balanced, calm, but beneath that calm, the balance was slipping. As oxygen accumulated in the atmosphere, it altered the chemistry of the air and the oceans. Methane, once abundant and powerful as a greenhouse gas, was broken apart by the presence of oxygen. Heat that had been trapped for eons began to escape into space. The Earth started to cool. Year by year, century by century, the change was imperceptible, but over geological time it was unstoppable. Ice sheets grew larger, reflecting sunlight back into space, accelerating the cooling even further. Each new layer of ice made the next one easier to form. The planet was caught in a feedback loop, slowly tightening its grip. Eventually, the ice did not retreat. It marched outward from the poles, creeping toward the equator, swallowing continents beneath kilometers of frozen weight. The oceans followed. Their surfaces sealed over, trapping liquid water beneath thick, unbroken ice. Earth had entered what scientists would one day call Snowball Earth. For the first time since its violent birth, the planet became almost completely still. From space, Earth would have appeared pale and lifeless, a white marble drifting silently around the sun. Clouds thinned, storms weakened. The atmosphere itself grew calmer, locked into a cold, static state. The surface was a frozen desert. No waves broke against shorelines. No rain fell from the sky. Wind scoured ice across endless plains of white. Sunlight reflected harshly off the frozen shell, offering little warmth in return. And yet life endured. Deep beneath the ice, where pressure and heat from the planet's interior kept pockets of water liquid, microbial life clung to existence. Near hydrothermal vents on the ocean floor, warmth and chemistry still flowed. These places became refuges, isolated islands of survival in a world of ice. Time slowed. Millions of years passed with little visible change. The planet seemed locked in eternal winter, its surface frozen, its skies quiet, its oceans sealed away. But Earth was not dead. Far below the ice, volcanoes continued to breathe. Magma rose through cracks in the crust, erupting beneath glaciers and oceans alike. Though the eruptions were muted by ice and water, they released gases into the atmosphere, carbon dioxide slowly accumulating without rain or weather to wash it away. The frozen world was quietly preparing for another transformation. As carbon dioxide built up, the atmosphere thickened once more. Heat began to linger. The ice, reflective and bright, started to absorb just enough warmth to weaken its grip. Cracks formed, dark water emerged in places, absorbing sunlight instead of reflecting it. The feedback loop reversed, melting accelerated, ice retreated faster than it had ever advanced. When the thaw finally came, it was sudden and violent. Glaciers collapsed, oceans surged. Torrential rains returned, falling onto a planet unprepared for water. Erosion reshaped the land. Rivers carved fresh paths across newly exposed continents. Earth had escaped its frozen prison, but the aftermath brought its own catastrophe. The rapid warming triggered intense chemical reactions in the oceans. Nutrients washed into the seas in enormous quantities, fueling explosive growth of life. Oxygen levels fluctuated wildly. Some organisms flourished, many others vanished. Extinction and creation unfolded side by side. From this chaos, something new emerged. Complex life began to experiment with form. Cells grouped together, cooperating instead of existing alone. Specialized structures developed. Early multicellular organisms appeared, fragile and strange, drifting through shallow seas. The planet had crossed another threshold, yet catastrophe was never far behind. As life diversified, the Earth's interior continued its slow, relentless motion. Continents drifted, collided, and broke apart. New mountain ranges rose, old ones were ground down into dust. Volcanic provinces formed, vast regions where lava poured out not for days or years, but for tens of thousands of years at a time. These eruptions altered the atmosphere, injecting enormous amounts of gas and ash into the sky. The climate wavered again. Periods of warmth gave way to cooling. Sea levels rose and fell. Ecosystems expanded, then shrank. Life adapted, diversified, and spread into nearly every corner of the oceans. For a time, it seemed resilient, unstoppable, but resilience has limits. Roughly 444 million years ago, another catastrophe unfolded, one that would claim much of the life that had only recently begun to flourish. The climate cooled abruptly. Glaciers returned, locking water away at the poles. Sea levels dropped dramatically, draining shallow marine habitats where most life existed. Vast continental shelves were left exposed to cold air and erosion. Species that depended on warm, shallow waters disappeared. As quickly as the cooling came, it reversed. Ice melted, seas returned, but the rapid warming proved just as deadly. Oxygen levels in the oceans plummeted. Survivors of the cold found themselves unable to breathe. This cycle of extremes wiped out a significant portion of Earth's life. The planet moved on. Life recovered, slowly filling the emptied niches. Fish developed jaws. Plants began to colonize land, creeping cautiously onto damp shorelines. Insects followed. Forests took root, transforming the atmosphere once again. Trees pulled carbon dioxide from the air and locked it into wood. Oxygen levels rose. The climate cooled. Earth was changing because of life now, not just in response to catastrophe, but as a driver of it. Then came fire. Lightning ignited dry forests. Flames spread across vast landscapes, reshaping ecosystems in hours. Fire became a new force on the planet, destructive, renewing, inevitable, but nothing compared to what was coming. Around 252 million years ago, Earth experienced the greatest catastrophe in its history. It began deep beneath the surface, where immense reservoirs of molten rock stirred. In what is now Siberia, the crust fractured, allowing lava to pour out on a scale never seen before. these eruptions did not stop. For hundreds of thousands of years, lava flooded the land, covering millions of square kilometers. Toxic gases filled the atmosphere: carbon dioxide, sulfur dioxide, methane. The climate swung violently, temperatures soared, oceans warmed, losing their ability to hold oxygen. Vast regions became anoxic, dead zones where nothing larger than microbes could survive. Acid rain fell, stripping forests and poisoning waterways. The food web collapsed. On land, heat and drought killed plants. Herbivores starved, carnivores followed. In the oceans, reefs vanished. Entire classes of organisms disappeared forever. This was the Great Dying. More than 90% of marine species were erased. On land, survival was rare. Life came closer to total extinction than at any other point in Earth's history. For a time, the planet seemed empty. Recovery took millions of years. Ecosystems rebuilt themselves from the few survivors that remained. New forms evolved, filling roles left vacant by extinction. From this devastation, the ancestors of dinosaurs emerged. They rose quietly at first, small and unremarkable, sharing the world with many other creatures. But as conditions stabilized, they diversified and spread, adapting to a wide range of environments. Earth entered a long period of relative calm. Warm climates prevailed, forests expanded, oceans teemed with life. Dinosaurs grew larger, more specialized, more dominant. For over 150 million years, they ruled the planet, but catastrophe was patient. Around 66 million years ago, an object from space crossed Earth's path. It was not the largest asteroid the planet had ever encountered, but it arrived at exactly the wrong moment. The impact struck near what is now the Yucatan Peninsula. In an instant, the energy released surpassed billions of nuclear explosions. Rock vaporized, shockwaves rippled through the crust. Tsunamis raced across oceans. Forests ignited thousands of kilometers away. Dust and debris were hurled into the atmosphere, blocking sunlight for months, perhaps years. Temperatures dropped, photosynthesis slowed. Food chains collapsed once again. This time the dinosaurs did not recover, but life did. Small mammals survived, sheltering underground, feeding on what little remained. Birds endured, plants returned. Slowly, quietly, the world reshaped itself. The age of mammals began. Ice ages came and went. Continents settled into familiar positions. Mountains rose, rivers carved valleys, grasslands spread. Eventually, a species emerged that could remember catastrophe and fear it. Humans learned to tell stories of floods, fires, and falling stars. They recorded disasters as myths, as warnings, as memories passed down through generations. But Earth's history shows something deeper. Catastrophe is not an interruption, it is the rhythm. After the dust settled, after the darkness lifted, and after the great reptiles vanished from the world, the Earth entered a quieter age. Not peaceful, never peaceful, but slower. The planet breathed differently now. Its climates shifted in long, deliberate cycles. Warm ages stretched on for millions of years, followed by gradual cooling, then warmth again. Life adapted not to stability, but to change itself. Mammals, once small and cautious, began to expand into the empty spaces left behind. They diversified quietly, experimenting with size, shape, and behavior. Forests filled with unfamiliar calls. Oceans welcomed new giants. The world felt full again. Yet beneath this renewal, the old forces continued their work. Continents drifted inch by inch, carried by currents deep within the mantle. When they collided, mountains rose. When they pulled apart, oceans widened. These movements altered wind patterns, redirected currents, and reshaped the climate in ways no creature could perceive at the time. Slowly, almost imperceptibly, the planet began to cool once more. Antarctica drifted toward the South Pole and settled there, isolated by a growing circumpolar current that trapped cold air and water around the continent. Ice accumulated, glaciers thickened. The southern ice cap became permanent. The world tilted toward cold. As temperatures dropped, ice crept outward again, not as a sudden catastrophe, but as a persistent pressure. Snow that once melted each year began to linger. Ice sheets expanded across northern continents, grinding landscapes beneath kilometers of frozen weight. This was the beginning of the ice ages. They did not come as a single event, but as a pulse: advance, retreat, advance again, each cycle lasting tens of thousands of years. During colder periods, sea levels fell as water locked itself into ice. Land bridges appeared, connecting continents that had long been separated. Animals migrated across these frozen corridors, following food, escaping cold, adapting or dying. Life learned to move. Grasslands spread across dry regions, replacing forests. Large herbivores followed the grasses. Predators followed the herds. Cold-shaped bodies, thicker fur, heavier frames, shorter limbs. The planet itself became an engine of selection. Within this shifting world, a lineage of primates began to change. They had once lived mostly in trees, feeding on fruit and leaves. But as forests shrank and grasslands expanded, survival demanded flexibility. These primates descended from the trees and learned to walk upright, freeing their hands for carrying, for shaping, for using. The first humans appeared not as conquerors but as survivors. They lived small lives, fragile lives, lives measured by hunger, weather, and chance. They were shaped by the climate more than they shaped it. Ice determined where they could go. Fire determined whether they could stay. Fire changed everything. First, it was feared. Lightning fires burned landscapes without warning, destroying shelter and food alike. But eventually, humans learned to keep fire alive, to carry it, to feed it. Fire brought warmth to frozen nights. It drove predators away. It transformed food, unlocking energy that raw flesh and roots could not provide. Fire allowed humans to endure the cold. As ice advanced again, humans followed the edges of glaciers, hunting large animals that thrived in open, frozen landscapes. Mammoths. Woolly rhinoceroses, giant deer, creatures perfectly adapted to cold and vulnerable to coordinated hunters. Humans spread across continents slowly over tens of thousands of years. They crossed frozen seas. They reached lands that had never known their presence before. Still, catastrophe ruled their world. Ice ages were not gentle. When glaciers advanced, they crushed forests and buried rivers. When they retreated, they unleashed floods that reshaped entire regions. Lakes formed and vanished. Coastlines shifted by hundreds of kilometers. Human populations rose and fell with the climate. Some groups thrived, others vanished without trace. Memory did not yet exist in written form, but the land remembered. Scars carved by ice remain etched into mountains and valleys even now. Then, around 20,000 years ago, the cold reached its peak. Ice sheets covered much of the northern hemisphere. Sea levels were at their lowest. Vast regions were locked beneath frozen silence. Deserts expanded elsewhere as moisture became trapped in ice. The world was harsh, demanding, unforgiving, and then once again it changed. The climate warmed. Glaciers began to melt, slowly at first, then faster. Rivers swelled beyond their banks. Meltwater poured into the oceans, raising sea levels and drowning coastlines. For humans, this warming was both gift and disaster. Hunting grounds vanished beneath water. Familiar routes disappeared, but new lands opened as ice retreated. Forests returned, plants spread, animals followed, humans adapted again. Some began to settle near reliable water sources. They learned the rhythms of seasons, they planted seeds, they stayed. Agriculture was born not from innovation alone, but from instability, from the need to control food in a world that could change without warning. With agriculture came cities. With cities came hierarchy. With hierarchy came new forms of catastrophe. Crowded settlements allowed disease to spread rapidly. Crops failed when rains did not come. Floods destroyed entire communities. Famine followed abundance as predictably as winter followed summer. Humans began to record catastrophe. Flood myths appeared across cultures, echoing memories of rising seas and sudden deluges. Stories of fire falling from the sky recalled distant impacts and volcanic eruptions. Tales of endless winter carried the memory of ice. Civilizations rose in fertile valleys carved by ancient floods, the Nile, the Tigris, the Euphrates, the Indus. These rivers gave life, but they also destroyed without mercy. The same waters that nourished crops could erase years of labor overnight. Empires expanded and collapsed. Droughts weakened societies. Earthquakes toppled cities. Volcanoes darkened skies and cooled climates, triggering famine far from their source. Human history became a mirror of Earth's deeper past, cycles of growth and collapse, resilience and ruin. Yet for the first time, a species began to alter the planet consciously. Forests were cut down, wetlands drained, rivers redirected. Carbon stored for millions of years was burned and released into the air. The atmosphere changed again, this time not because of volcanoes or microbes, but because of intention. The climate began to warm. At first, the change was subtle, a degree here, a season there, but Earth has always responded strongly to small shifts. Ice retreated once more. Glaciers thinned, sea levels rose, storms intensified as warmer air held more moisture. Patterns humans had depended on for centuries became unreliable. The old catastrophes returned in new forms. Floods struck cities built on ancient floodplains. Wildfires burned forests dried by heat. Droughts emptied reservoirs. Storms grew stronger, their paths less predictable. Unlike previous ages, this time catastrophe arrived alongside awareness. Humans could measure it, record it, argue about it, fear it, but awareness did not grant control. The Earth continued to follow its laws, energy seeking balance, heat moving toward cold, systems adjusting to pressure. The planet has never promised safety. What history reveals, quietly and relentlessly, is that catastrophe is not an exception to the story of Earth. It is the story. From fire to ice, from impact to extinction, from silence to renewal, the world has been shaped not by stability, but by disruption. Life persists not because catastrophe ends, but because it never quite finishes the job. The ground beneath us is ancient. The sky above us has changed many times before. The future will not resemble the present for long. The present feels solid. The ground beneath our feet seems fixed. The sky feels familiar. Seasons arrive more or less on schedule. Cities glow at night, rivers follow mapped courses, coastlines appear stable on the scale of a human lifetime. But the Earth has never measured time the way we do. To the planet, the present moment is thin, a narrow pause between movements that began long ago and will continue long after memory fades. The forces that shaped ancient catastrophes are still here, still active, still patient. They have not ended. They have only slowed enough for us to notice them. Beneath the continents, tectonic plates continue to drift. They move no faster than fingernails grow, yet they carry mountains, oceans, and civilizations with them. Pressure builds silently where plates meet. Stress accumulates, locked into stone. For centuries, nothing happens, and then without warning, the ground remembers. Earthquakes rupture the surface in seconds, releasing energy stored for millennia. Cities fall, coastlines shift. The land rearranges itself without concern for what was built upon it. This is not punishment, it is release. Volcanoes behave the same way. For generations, a mountain may appear calm, forests on its slopes, snow at its peak, villages settled confidently at its base. Beneath that calm, magma rises slowly, collecting, heating, expanding. Pressure builds. When the release finally comes, it may take hours or it may take decades. Lava flows erase roads. Ash darkens skies. Ops fail far from the eruption itself as sunlight weakens and temperatures fall. The earth exhales. These events feel sudden to us because we experience only the moment of change, not the long preparation beneath it. But from the planet's perspective, nothing about them is abrupt. They are inevitable. Water, too, follows this pattern. Rivers carve valleys grain by grain. Glaciers grind mountains into dust over tens of thousands of years. Waves eat away at coastlines, removing millimeters at a time. Then occasionally water moves all at once. Floods submerge entire regions overnight. Storm surges erase neighborhoods. Ice dams fail, releasing inland seas in a matter of days. The land reshapes itself again just as it always has. What is different now is not the process, it is the presence of observers. Humans have built their lives during a relatively calm interval, a brief warming period between ice ages known as an interglacial. Agriculture, cities, and written history all emerged during this narrow window of stability, but stability has always been temporary. As greenhouse gases accumulate in the atmosphere, the planet responds in familiar ways. Heat redistributes, ice melts, oceans expand, weather patterns shift. These are not new behaviors, they are ancient reflexes. The Earth does not distinguish between causes. Whether carbon enters the atmosphere from volcanoes, microbes, or machines, the result is the same. Energy must balance, systems must adjust, and adjustment always carries consequences. As temperatures rise, ice sheets lose mass. Their retreat accelerates as darker land and water absorb more sunlight. Sea levels creep upward not dramatically but persistently. A few millimeters each year, enough to flood low islands, enough to salinize groundwater, enough to force migrations that echo those of earlier ages. The ocean warms as well, expanding as heat penetrates deeper layers. Currents shift, storms draw more energy from warmer waters, becoming stronger, wetter, slower. Rain falls where it once did not. Drought grips regions once fertile. Familiar patterns dissolve. Life responds as it always has by moving, adapting, or disappearing. Species shift their ranges toward cooler climates. Some succeed, many do not. Ecosystems unravel as relationships formed over thousands of years break apart. Extinction returns not as a single dramatic event, but as a quiet thinning. One species gone, then another, then another. The planet has witnessed this before. 5 times in the past, mass extinctions reshaped life on Earth. Each time recovery followed, new forms emerged, complexity returned, but recovery does not mean restoration. What comes back is never what was lost. The Earth does not rewind. It moves forward, carrying the memory of change within its chemistry, its geology, its living systems. Humans, for the first time, can see this happening in real time. Satellites track melting ice, instruments measure rising seas, records show shifting seasons, and still the scale of the process remains difficult to grasp, because catastrophe on a planetary scale rarely looks like a single moment. It looks like a trend. It looks like slow erosion of certainty. It looks like familiar places becoming unfamiliar. In the past, catastrophes often arrived from outside, asteroids falling from space, eruptions rising from deep within the Earth. Today's changes arise from within the biosphere itself, from a species that learned to unlock ancient carbon and release it into the air. This, too, is not unprecedented. Long ago, microscopic organisms altered the atmosphere by releasing oxygen, triggering one of the greatest extinctions the planet had ever seen. They did not intend harm, they followed energy. Humans are doing the same. The difference lies not in the effect, but in the awareness. For the first time, a species understands that it is participating in a planetary process. Yet understanding does not grant exemption. The Earth does not negotiate. As ice melts, pressure on the crust shifts. Regions once weighed down by glaciers rebound upward. Others sink. Faults adjust. Seismic patterns change subtly but meaningfully. As oceans warm and expand, stress on coastlines increases. As permafrost thaws, methane escapes, amplifying warming. Feedback loops tighten just as they did during ancient climate shifts. The past repeats its patterns, wearing new faces. Fire returns as well, warmer temperatures dry landscapes. Lightning ignites forests primed to burn. Fires grow larger, hotter, harder to control. Smoke travels across continents, dimming skies far from the flames. Fire clears ecosystems as it always has. But when it burns too often, too intensely, recovery falters. The balance tips, still life persists. Plants sprout in burned soil. Animals recolonize altered habitats. Microbes flourish in warming oceans. Evolution does not stop because conditions are uncomfortable. It accelerates. What follows catastrophe is not emptiness, but transformation. This has always been the pattern. Even now, beneath the noise of modern life, the planet continues its ancient work. Mountain ranges rise and erode. Sediment settles into new layers that will one day become rock. Oceans absorb heat and carbon, changing their chemistry in slow, measurable ways. These layers will remain long after cities crumble. Future geologists, human or otherwise, will read this time in stone. They will see a thin band of unusual chemistry, plastics, altered isotopes, sudden extinctions. They will know that something changed here, and then the record will continue, because catastrophe does not end the story, it advances it. Earth has never been fragile, it has been relentless. It endures through change not by resisting it, but by incorporating it. The planet absorbs disruption and moves on, reshaped but intact. Life, too, endures, though not always in familiar forms. The question has never been whether Earth will survive catastrophe. It always does. The quieter question, the one whispered beneath all others, is which forms of life will remain to witness what comes next. Far beyond the span of recorded memory, beyond the reach of stories and names, the Earth continues. It does not pause to reflect on what has been lost. It does not hold nostalgia for vanished species or drowned coastlines. It moves forward, shaped by physics, chemistry, and time, the same forces that guided its earliest catastrophes. Long after the present moment has faded into geology, the continents will begin to rearrange themselves once again. Africa will continue its slow collision with Europe, closing the Mediterranean Sea grain by grain. Mountain ranges will rise where shallow waters once reflected the sky. Australia will drift northward, merging with Southeast Asia. The Atlantic Ocean will widen for a time, then begin to close as tectonic motion reverses. A new supercontinent will form. It may take hundreds of millions of years, but the pattern is inevitable. Continents gather, collide, fuse, and tear apart in cycles older than complex life itself. Each configuration reshapes ocean currents, wind patterns, and climate. When land gathers into a single mass, the interior grows dry and extreme. Deserts expand, seasons sharpen, life concentrates along coasts, clinging to the edges of habitability. Then the continent fractures, oceans flood new rifts. Moisture returns inland, life spreads, diversifies, adapts. This cycle will repeat long after human cities are ground into sediment. The climate, too, will continue its long oscillation. Ice ages will return, they always do. Even if warming dominates for thousands or tens of thousands of years, orbital shifts will eventually reduce sunlight reaching the poles. Snow will persist, ice will grow. Glaciers will advance once more, carving new valleys atop the ruins of old ones. Sea levels will fall. Land bridges will reappear. Species will migrate again just as they did before. Whether humans remain to witness these changes is uncertain. The planet does not require observers. As time stretches forward, the sun itself will change. It has always been changing. Very slowly, almost imperceptibly, the sun grows brighter as it ages. Each billion years, its energy output increases slightly. What feels stable now is only a temporary balance. In the distant future, increased solar radiation will warm the Earth beyond familiar limits. Oceans will evaporate faster. The atmosphere will trap more heat. Water vapor, a powerful greenhouse gas, will amplify the warming. The planet will move toward a moist greenhouse state. Clouds will thicken. Rainfall will intensify, then diminish as oceans shrink. Rivers will dry. Ice will vanish completely. The poles will no longer be cold. Life will retreat toward higher latitudes and elevations, chasing tolerable temperatures. Eventually, even these refuges will fail. The oceans, which once sheltered life through ice and fire, will thin and fade. Hydrogen will escape into space. What remains will be a hotter, drier world, not suddenly, gradually. So gradually that millions of generations could live and die without noticing the full arc of the change. Mass extinctions may occur during this transition, not from impacts or eruptions, but from the slow loss of habitability. Species adapted to water-rich environments will vanish. Those able to endure heat and drought may persist for a time. Microbial life will likely be the last to remain, hidden in protected niches, enduring conditions far harsher than anything complex organisms could survive. And still, catastrophe will not be dramatic. There will be no single moment of ending. Just a long fading. Far later still, billions of years from now, the sun will begin its final transformation. It will swell into a red giant, expanding outward, engulfing the inner planets. Mercury will vanish. Venus will be erased. Earth's fate is uncertain. It may be consumed, or it may survive as a scorched, airless remnant, stripped of oceans and atmosphere. By then, the planet will be unrecognizable. The surface will melt. Rock will flow once more. Whatever remains of the crust will be recycled into a glowing shell, echoing the conditions of Earth's violent birth. The circle will nearly close. If Earth survives this phase, it will emerge as a barren world, silent, lifeless, and altered beyond recovery. The sun will shed its outer layers, leaving behind a white dwarf, dim and fading. The solar system will cool. Asteroids will continue to drift. Comets will pass silently. The remnants of planets will orbit a shrinking star, their histories locked into stone and orbit. The Earth's long experiment with life will be over. But catastrophe, even then, will not be failure. It will be completion, because the story of Earth has never been about permanence. From its first moments as a molten sphere, through ice-bound silence and fire-driven extinction, through forests, oceans, and thinking beings, the planet has existed in a constant state of becoming. Every catastrophe reshaped the conditions for what followed. Every ending cleared space for a beginning. Even now, in the present moment, the Earth stands between states neither stable nor collapsing, but changing as it always has. The human instinct is to see catastrophe as something to be avoided at all costs, to imagine that a perfect balance can be preserved indefinitely if only the right actions are taken. But the deeper truth, written into the planet itself, is more subtle. Balance is temporary. Change is constant. Survival belongs not to what resists catastrophe, but to what moves through it. Life has persisted on Earth not because the planet is gentle, but because it is relentless, because it tests, erases, and rebuilds again and again across spans of time that dwarf fear and hope alike. In this sense, catastrophe is not the opposite of life, it is its engine. What matters is not whether catastrophe comes, it always does, but what follows, what adapts, what remains. What emerges in the quiet aftermath. The earth does not mourn its past, it carries it forward. And long after the last familiar shape has vanished, long after memory itself has faded, the planet will still bear the marks of everything it has been, etched into layers of stone, folded into the chemistry of its crust, orbiting quietly through space. The story does not end in silence, it returns to it, and from silence, given enough time, something always begins again. After the last oceans have thinned into memory, after forests have vanished and mountains have softened into low, featureless stone, the earth does not stop. It has never stopped. What remains is a quieter world, stripped of the movement and color that once defined it, yet still governed by the same ancient laws that shaped every catastrophe before. Heat continues to flow from the planet's interior. Gravity still binds what is left together. Time continues, indifferent to absence. The surface, now dry and exposed, endures extremes unknown to the living earth of the past. Without oceans to moderate temperature, days grow brutally hot and nights fall into deep cold. Rock expands and contracts, cracking, splintering, slowly turning mountains into dust. Wind becomes the dominant sculptor. It carries fine particles across vast distances, smoothing sharp edges, filling low places, erasing contrast. What were once continents become broad, gently undulating plains, marked only by subtle variations in mineral color. Occasionally, far beneath the surface, molten rock still rises. Volcanoes erupt, though their eruptions are different now. Without water or atmosphere to shape them, lava flows silently across the surface, cooling slowly, adding fresh layers to the crust. Each eruption rewrites the land in small, patient increments. The earth is still active, still evolving, still changing even without life to witness it. The moon continues its steady retreat, drifting farther away with each passing million years. Tides, once powerful engines shaping coastlines and ecosystems, no longer exist. The bond between Earth and Moon weakens, though it never fully breaks. The planet spins more slowly now. Days stretch longer, nights deepen. The sky, thin and altered, no longer scatters light the way it once did. Sunrises are harsher, shadows sharper. The sun itself looms larger in the sky than it once did, its warmth more intense, its light more unforgiving. Though still far from its final expansion, its influence is undeniable. And yet, even in this stripped-down state, Earth retains memory. Every layer of rock carries a record of what came before. Fossilized shorelines etched into cliffs that no longer meet the sea. Sedimentary layers formed from ancient rivers that once flowed endlessly. Chemical signatures marking moments when the atmosphere shifted suddenly, catastrophically. These records persist far longer than life ever did. If a distant intelligence were to arrive now, drifting through the cold emptiness of space, it might see Earth as unremarkable at first glance. A rocky world, scarred but quiet, orbiting an aging star. But if it looked closely, it would see something unusual. The planet's crust would tell a story of extraordinary transformation. It would reveal a world that once froze completely, then burned, then bloomed with oceans and forests. A world that suffered repeated mass extinctions, yet rebuilt itself again and again. A world that briefly hosted a species capable of altering its atmosphere and questioning its own impermanence. That story would not be written in words, it would be written in stone. Time would continue to move forward, pulling Earth along with it. Millions of years pass, then tens of millions. Impacts still occur, though less frequently now. Asteroids strike the barren surface, carving fresh craters that remain sharp and visible for eons. Without erosion from water or vegetation, scars persist almost unchanged. Each impact is a reminder of the planet's earliest days when such collisions were constant, shaping everything. In this sense, the Earth returns to its origins. The cycle tightens. Far in the future, as the sun grows more unstable, solar winds intensify. Whatever remains of Earth's atmosphere is stripped away completely. The sky fades into near vacuum. Radiation bathes the surface. The planet becomes more like Mercury, a world of extremes, silent and exposed. Still, the core remains warm. Radioactive elements continue to decay, releasing heat slowly, steadily. This heat drives the faint movement of the mantle, the last echo of tectonic life. Eventually, even this fades. The core cools. The magnetic field weakens and disappears. The planet becomes fully passive, responding only to external forces. But this is not death, it is completion, because Earth was never meant to last forever in any single form. Everything about its history points to transformation as the only constant. The violent birth, the frozen silences, the fiery extinctions, the long, improbable flourishing of life, the rise of awareness, the slow fading. Each phase flowed into the next, not as an error or deviation, but as a consequence of what came before. In the deepest sense, catastrophe was never an interruption to Earth's story. It was the structure of the story itself. The human mind often seeks meaning in survival, imagining that endurance implies purpose. But Earth's endurance does not come from clinging to a particular state. It comes from allowing change to reshape it entirely. Life, too, followed this pattern. Species that thrived were not those best suited to a single environment, but those flexible enough to adapt as conditions shifted. When adaptation failed, extinction followed, not as punishment, but as transition. The fossil record is not a graveyard, it is a ledger of experiments, some short-lived, some astonishingly long, all temporary. This perspective reshapes how catastrophe appears. What feels like an ending when viewed from within a single lifetime becomes a turning point when viewed across deep time. What feels unbearable on human scales becomes almost gentle when spread across millions of years. This does not diminish loss, but it places it within a broader rhythm. The Earth has always balanced creation and destruction, not as opposing forces, but as partners. Mountains rise because plates collide. Oceans exist because basins form. Life flourishes because nutrients are released by erosion and decay. Even mass extinctions, devastating as they are, create opportunity for new forms to arise. Without the great dying, dinosaurs would not have inherited the world. Without the asteroid impact, mammals would not have expanded into dominance. Without repeated climate shifts, humans might never have evolved the flexibility that defined them. Catastrophe did not oppose life, it shaped it. In the far future, long after Earth's surface has quieted and its atmosphere has vanished, this truth remains embedded in the planet's structure. The scars are not erased, they are integrated. The Earth does not forget. It carries every impact, every eruption, every freeze and thaw within itself, layered and compressed, waiting to be uncovered by time or chance. Even when nothing remains to remember consciously, memory persists physically. This is the deepest continuity Earth offers. Not survival of form, but survival of record. Eventually, the sun's transformation accelerates. Its outer layers swell and drift outward, glowing red, unstable. The inner solar system becomes hostile beyond imagination. Radiation intensifies, orbits destabilize slightly as mass is lost. If Earth remains intact, it will endure conditions similar to its earliest moments: molten surface, vaporized rock, a world remade by heat. If it does not remain intact, its fragments will scatter, joining the countless remnants of other worlds that formed and unformed across the galaxy. Either outcome fits the pattern. Nothing in Earth's history suggests permanence. Everything suggests participation in a larger cosmic process: stars forming, planets assembling, life emerging, systems dissolving, matter returning to space. From that space, new stars will form, new planets will gather, new catastrophes will shape new worlds. The cycle does not belong to Earth alone, it belongs to the universe itself. In this sense, Earth's story is not unique, it is exemplary. It shows how matter organizes, destabilizes, and reorganizes across vast spans of time, how complexity arises not in spite of disruption but because of it. The universe does not avoid catastrophe, it depends on it. Supernovae seed space with heavy elements. Collisions form planets, instabilities create structure. Without destruction, there is no diversity. Earth is one chapter in this endless process, a particularly rich one. A chapter where stone learned to host oceans, where chemistry learned to replicate, where awareness briefly looked back at its own origins and asked why. That question may fade, but the conditions that allowed it to be asked remain part of the cosmic record. Even now, as you listen to this story, catastrophe continues elsewhere. Stars explode, galaxies collide. Planets freeze and burn and shatter, and somewhere perhaps life begins again in quiet pools beneath alien skies, unaware of how fragile and how resilient it will need to be. Earth does not offer comfort, it offers perspective. It reminds us that stability is borrowed, not owned. That existence is shaped by forces beyond intention. That meaning, if it exists, arises within impermanence, not beyond it. The ground beneath you is older than fear. The sky above you has changed many times before. The future will not resemble the present for long, and yet here you are, a brief configuration of matter, aware of the long chain of catastrophes that made awareness possible at all. This is not insignificant, it is extraordinary, because to witness Earth's story even briefly is to stand at the intersection of chaos and continuity, to see that endings and beginnings are not opposites but reflections of the same movement through time. The Earth does not promise that what exists now will endure. It promises only that change will continue, and that somehow, through fire and ice, through silence and upheaval, something will always follow what came before, even after the end. Even after the last familiar shape has faded, time will continue, matter will move, and somewhere in some form, the quiet work of becoming will begin again. Long after the last echo of oceans has faded, after the final mountains have been worn smooth and the memory of forests has vanished into stone, the earth enters a state that feels like rest. But it is not rest. It is simply a slower motion, a deeper stillness within which change continues at a pace almost impossible to sense. The planet drifts through space, bound to its star, carrying the accumulated weight of everything it has been. The scars of catastrophe are still there, softened, blurred, layered beneath newer marks, but they have not disappeared. Nothing ever truly disappears on a planetary scale. It is only transformed, folded inward, compressed into new arrangements. The Earth has always existed in dialogue with its surroundings. Gravity pulls it forward, radiation shapes its surface. Impacts remind it of the chaos from which it emerged. Even in its quietest eras, the planet has never been alone. The solar system itself is not static. It moves through the galaxy, orbiting the dense center of the Milky Way, passing through regions of varying stellar density. At times, nearby stars drift close enough to disturb the distant edges of the system, nudging comets inward, altering orbits, sending frozen remnants toward the inner planets. In Earth's distant past, such events may have triggered periods of increased impacts. In the far future, they may do so again. Catastrophe can arrive not only from within or nearby, but from far beyond. Even now, unseen objects pass silently through the solar system, their paths curved by gravity, their presence unnoticed unless they cross too close to something solid. Space is vast, but it is not empty, and time ensures that chance encounters eventually occur. If in some distant epoch a massive object were to strike the Earth again, it would not be the first, nor the last. The impact would carve a fresh wound into the ancient crust, melting rock, reshaping landscapes that have already been reshaped countless times before. The Earth would absorb it. It always has. The absence of life does not make catastrophe more meaningful nor less. It simply removes witnesses. The physical processes remain the same: energy released, matter displaced, heat redistributed. This indifference is not cruelty, it is consistency. The universe operates without preference, without memory, without regret. It follows rules that do not bend to comfort or fear. Earth's history is a record of those rules playing out under specific conditions over vast spans of time. In this light, catastrophe becomes less a singular event and more a mode of transformation. Something changes, pressure releases, energy moves, structure rearranges. Then the system settles into a new configuration. This pattern repeats endlessly, from the smallest chemical reaction to the largest cosmic collision. Earth's story fits neatly within this pattern. In its earliest days, catastrophe dominated because the system was young and unstable. Later, catastrophes became less frequent but more complex, interacting with life and climate in intricate ways. In its final stages, catastrophe returns to simplicity: heat, impact, erosion, stripped of biological complication. But the underlying rhythm never changes. What we call catastrophe is simply change perceived from within a system that values continuity. From outside, it is just motion. The Earth has crossed many thresholds in its long existence. Each threshold marked a shift in dominant processes, from accretion to differentiation, from molten chaos to crust and ocean, from chemistry to biology, from biology to awareness. Each threshold introduced new forms of instability. Life made the atmosphere reactive. Oxygen made fire possible. Awareness made fear possible. With each new layer of complexity came new kinds of catastrophe. When the Earth was lifeless, catastrophe reshaped stone. When life emerged, catastrophe reshaped ecosystems. When humans appeared, catastrophe reshaped meaning. And when awareness fades, catastrophe returns to reshaping matter alone. This progression is not a climb toward perfection. It is an expansion of possibility. Complex systems allow for more ways to fail, but also more ways to persist. Earth explored those possibilities thoroughly. It allowed life to take root, knowing that life would sometimes erase itself. It allowed intelligence to arise, knowing that intelligence would alter its environment in unpredictable ways. Nothing in the planet's history suggests restraint, only allowance. This is perhaps the most unsettling truth embedded in deep time. The Earth does not protect what emerges upon it. It provides conditions. What happens within those conditions is subject to chance, adaptation, and inevitability. In this sense, catastrophe is not external to life. It is part of life's operating environment. Species do not evolve to avoid catastrophe entirely. They evolve to endure its frequency, its scale, its aftermath. When catastrophes exceed those adaptive limits, extinction follows. Then evolution resumes elsewhere with different starting points. The fossil record shows this clearly. Diversity drops sharply during mass extinctions, then rebounds, often surpassing previous levels. But the composition changes. The survivors are not better versions of what came before, they are different. The Earth does not repeat itself exactly. It rhymes. Even without life, this principle holds. The planet's surface is never reshaped in precisely the same way twice. Erosion patterns differ. Impact angles vary. Volcanic flows follow new paths. Each transformation builds on what remains from before. The Earth accumulates history rather than replacing it. This accumulation creates depth, physical, chemical, and temporal depth. In that depth, the story of catastrophe becomes less about destruction and more about layering. Each disaster leaves behind a trace that influences what comes next. A crater becomes a basin becomes a lake becomes sediment becomes stone becomes mountain becomes dust. Dust becomes something else. Nothing is wasted, nothing is final. Even the quietest Earth still participates in this cycle, and beyond Earth the cycle continues at larger scales. Stars form from collapsing clouds of gas ignited by pressure and gravity. They burn steadily for millions or billions of years, creating heavier elements in their cores. When they exhaust their fuel, they die, sometimes gently, sometimes violently. Their deaths scatter those elements into space. From that debris, new stars and planets form. Every atom of iron in Earth's core was forged in a stellar catastrophe long before the sun existed. Every atom of oxygen in ancient oceans was created in the heart of a dying star. Catastrophe made the Earth possible. This is not metaphor, it is literal history. The universe builds complexity through disruption. Without collapse, nothing concentrates. Without explosion, nothing spreads. Earth's catastrophes are local expressions of a universal process. In this context, the fear that catastrophe inspires becomes understandable, but also incomplete. Fear arises from attachment to a particular configuration, a species, a climate, a way of life, but the universe does not privilege configurations, it privileges processes. Change is the only enduring feature. This does not mean that suffering is meaningless. On human scales, loss matters profoundly. Pain is real. Memory is real, experience is real, but on planetary scales, meaning operates differently. Earth's story is not about preserving comfort, it is about exploring possibility. The planet explored ice-bound stagnation and fire-driven renewal. It explored microbial dominance and complex ecosystems. It explored awareness and its consequences. Each exploration ended. Each left behind conditions for something else. If awareness does not persist into the far future, that does not negate its existence. It simply situates it, like a brief flare in deep time, bright, transformative, gone, yet still part of the whole. As the Earth continues to age, as its internal heat dwindles and its surface quiets, it approaches a state of equilibrium, not perfect balance, but minimal activity. This state will last far longer than the era of life ever did. For billions of years, the planet may exist as a silent archive, orbiting a fading star, carrying within it the compressed record of oceans, atmospheres, and minds. Then eventually even this archive may be erased. The sun's final transformations may melt and remix the crust entirely, or gravitational interactions may eject Earth from its orbit, sending it drifting into interstellar space as a rogue planet, cold and dark. Even then, the story does not truly end. The planet's matter will continue to exist. Atoms do not vanish when systems dissolve. They move on. Perhaps they will become part of another world. Perhaps they will remain locked in stone forever. Perhaps they will be pulled into a new star, recycled once more. Whatever the outcome, Earth's catastrophes will have contributed to something beyond themselves. This is the quiet continuity that underlies all endings. Nothing stops. It only changes scale, context, and form. When we look back across Earth's history, what stands out is not the disasters themselves, but the persistence of process. Accretion gave way to erosion. Eruption gave way to sedimentation. Extinction gave way to diversification. Awareness gave way to record. Even silence gives way to motion. This is the deeper rhythm beneath the noise of catastrophe. It is slow, relentless, unemotional, and endlessly creative. Earth has been many worlds, it will be many more. The planet we recognize is only one version among countless others, briefly illuminated by life and thought. What comes next does not need to resemble what came before. It only needs to follow the same laws. To understand catastrophe fully, one must stop seeing it as a series of events and begin hearing it as a single motion. Not impacts, not eruptions, not extinctions, but movement. From the very first moment matter began to gather, catastrophe was already present, not as destruction, but as compression. Dust collapsed under gravity, energy surged, temperature rose, structure formed because chaos allowed it to. The universe did not begin gently, it began by breaking symmetry. And Earth inherited that inheritance. The planet's history reads like a long conversation between order and instability, where neither side ever truly wins. When systems grow too rigid, pressure builds. When pressure releases, systems reorganize. This is as true for continents as it is for climates, ecosystems, and civilizations. Catastrophe is the language through which that conversation proceeds. Early Earth had no choice but to be catastrophic. Young systems are unstable by nature. They are full of excess energy, unresolved gradients, incomplete structures. Impacts, volcanism, and atmospheric loss were not deviations. They were the process of settling. Each collision refined Earth's mass. Each eruption differentiated its interior. Each loss forced replacement. Stability emerged only when energy flows slowed enough to allow persistence. Even then, persistence was conditional. The oceans existed only because the planet cooled within a narrow range. The atmosphere endured only because gravity and magnetic shielding were sufficient. Life arose only because chemistry found temporary balance. Every success sat atop countless failures. This is not pessimism, it is arithmetic. When we compress billions of years into a single narrative, catastrophe appears frequent and dramatic. In truth, most of Earth's time passed in long stretches of relative quiet, punctuated by moments of rapid change. But those moments mattered disproportionately. They redirected trajectories. They erased dominant forms and allowed marginal ones to expand. They reset conditions. In this way, catastrophe functioned less like an executioner and more like a selector. The planet did not choose what survived, it tested what could. When oxygen flooded the atmosphere, it did not intend to kill anaerobic life. It simply accumulated. Those unable to tolerate it vanished. Those able to adapt thrived. When ice locked the planet in white silence, it did not target complexity. It altered energy balance. Life retreated to refuges. Survivors emerged changed. When volcanoes poisoned oceans and heated the sky, they did not discriminate. They pushed conditions beyond thresholds. Most systems collapsed. A few endured. This pattern repeats at every scale. Pressure builds. Thresholds are crossed. Systems reorganize. Catastrophe is not a single force. It is the crossing of limits, and limits exist everywhere. The earth is full of thresholds, points beyond which gradual change becomes abrupt transformation. Ice albedo feedbacks, ocean circulation collapses, atmospheric chemistry shifts, tectonic stress releases. These thresholds are invisible until crossed. Once crossed, return is difficult or impossible. This is why catastrophe feels sudden even when it has been preparing for ages. The system appears stable until it is not. Human history, compressed into mere moments of geological time, follows the same structure. Civilizations rise during stable climate intervals. They build infrastructure optimized for familiar conditions. They grow dependent on predictable patterns. When those patterns shift, droughts lengthen, floods intensify, temperatures drift, stress accumulates. Institutions strain, inequalities widen, conflict increases. Eventually, a threshold is crossed, collapse follows. Not because catastrophe arrived from nowhere, but because resilience was exceeded. This does not mean collapse is inevitable in any given moment. It means that resilience has limits. Earth has always operated this way. Forests thrive until fire returns nutrients to soil. Rivers meander until floods reset channels. Populations grow until resources tighten. Balance is not static, it oscillates. The deeper we look into Earth's past, the clearer this oscillation becomes. There was never a golden age without catastrophe. There were only intervals between adjustments. Even the long reign of the dinosaurs, often imagined as a stable era, was punctuated by climate swings, sea level changes, and regional extinctions. Their dominance persisted not because conditions were gentle, but because they adapted well to variability. When variability exceeded their adaptive range, they disappeared, not all at once, but decisively. The same principle governs the future. Whether life continues on Earth or not, whether intelligence persists or fades, catastrophe will remain the mechanism through which change occurs. This is not a flaw, it is function. Without catastrophe, gradients would flatten, energy would stagnate, complexity would decay. Disruption keeps systems dynamic. The Earth's interior illustrates this clearly. Heat flows outward from the core, driving mantle convection. That convection moves plates. Plate motion builds mountains and opens oceans. Mountains erode, feeding sediments into seas. Sediments alter chemistry, supporting life. If the interior cooled completely, this cycle would halt. The surface would become static. Life would lose one of its most important engines of renewal. Catastrophe in the form of tectonics is what keeps the surface alive. Similarly, climate variability, storms, droughts, freezes, redistributes energy and nutrients. It prevents monopolies. It breaks dominance. It allows turnover. Too much variability kills, too little stagnates. Earth has always danced between these extremes. This dance is not choreographed. It emerges from competing processes seeking equilibrium. When viewed this way, catastrophe loses its moral dimension. It is neither good nor evil. It is necessary. This does not lessen the pain it causes within systems that value continuity, but it reframes that pain as part of a larger motion rather than a failure. The Earth does not promise safety. It promises motion. Every layer of stone beneath your feet is a frozen moment in that motion. Each layer represents a former surface, a former present, once alive with activity, now silent. Those layers were once future. They were once uncertain. They were once everything. Now they are foundation. This is what catastrophe ultimately does. It turns futures into pasts, and pasts into structure. In deep time, nothing is wasted. Even extinction becomes substrate. When life disappears, its remains become nutrients, its shells become limestone, its carbon becomes fuel for future chemistry. Death feeds continuation. This is why Earth never truly resets to zero. It accumulates. The planet's chemistry today reflects everything it has endured, every ice age, every eruption, every biological innovation. The present is not a clean slate, it is a composite. This accumulation creates inertia. The more complex a system becomes, the harder it is to change quickly, until change finally comes and it is immense. This is why mass extinctions are rare but transformative. They occur only when accumulated stresses overwhelm buffering capacity. When they do, the reorganization is profound. Earth has experienced this at least 5 times on a global scale. Each time the biosphere simplified dramatically. Each time recovery followed slower, different, more complex in new ways. This pattern suggests that life is resilient not because it avoids catastrophe, but because it exploits aftermath. After destruction, resources are abundant, competition is reduced, niches are open, innovation thrives in emptiness. This is as true for biology as it is for geology. Volcanic islands are barren at birth, then lichens arrive, then plants, then forests. Each stage prepares the ground for the next. Catastrophe creates opportunity by clearing constraints. This principle applies even to awareness. Human culture has often advanced rapidly after disruption, migrations, collapses, crises forcing adaptation. Comfort preserves, pressure transforms. The earth does not favor comfort, it favors transformation. When we project into the far future, imagining the planet long after familiar life has vanished, this principle still holds. The absence of life does not mean absence of change, it means change has shifted domains. Chemical weathering replaces biological cycling. Thermal cracking replaces erosion by roots. Impact gardening replaces ecosystem turnover. Different processes dominate, but the rhythm persists. Even in a silent world, catastrophe continues, quieter, slower, but no less real. This continuity reveals something subtle. Catastrophe is not what ends worlds, it is what allows worlds to evolve. A world without catastrophe would be static. A static world would be dead in a deeper sense, incapable of novelty, incapable of complexity, incapable of memory. Earth's catastrophes gave it character, they gave it history, they gave it depth, and within that depth consciousness briefly emerged not as an inevitable outcome but as a possibility realized under specific conditions. That consciousness now looks back and names what it sees. It calls some changes disasters, others it calls progress. But from Earth's perspective, there is no distinction. There is only motion through states. This perspective can feel unsettling. It removes the illusion that the present moment is central or protected, but it also offers clarity. It shows that nothing is wrong when change accelerates. It shows that uncertainty is not a sign of failure. It shows that endings are not violations of order, but expressions of it. The earth has been ending since it began, and it has been beginning ever since. This is the paradox at the heart of deep time. Every ending creates the conditions for something else. Even silence is not final. It is simply a different configuration of matter and energy waiting for new gradients to form. In the cosmic sense, the Earth is never finished. It is always mid-process. Even its eventual destruction, whether by solar expansion, collision, or dissolution, will not erase it from existence. It will transform it. The atoms that once formed mountains and oceans will continue. They will participate in other structures. They will tell other stories. Catastrophe is the mechanism by which those stories change. When we understand this, fear gives way to perspective, not comfort, not certainty, but perspective. The earth does not owe continuity to any particular form. It offers continuity to process itself, and that is enough, because from process arises everything that has ever existed. And from process will arise whatever comes next. Between beginnings and endings, there is always a middle. it is easy to miss because the middle rarely announces itself. It does not arrive with explosions or disappear in silence. It unfolds slowly, layered with contradictions, filled with movement that feels ordinary while it is happening and monumental only in retrospect. The Earth has spent most of its existence in this middle state, not forming, not ending, but becoming. After the great catastrophes that reshaped its surface and thinned its living world, after extinctions cleared space and recoveries filled it again, the planet often entered long intervals of relative balance. These were not peaceful ages in the human sense. Storms still raged, volcanoes still erupted, species still vanished, but the overall structure held. These long middles are where complexity accumulates. Rivers learn their courses, forests deepen their roots. Oceans settle into circulating patterns that last for millions of years. Life, given enough time without overwhelming disruption, explores its possibilities. It branches, it experiments, it fills space with diversity. Yet even in these extended middles, catastrophe never leaves. It simply changes its expression. Instead of global extinctions, there are regional collapses. Instead of planetary freezes, there are shifting climate belts. Instead of impacts that darken the sky, there are slow changes in chemistry that quietly favor some forms of life over others. The middle is shaped by gradients. Where energy flows steadily, systems persist. Where gradients sharpen, instability grows. Where instability grows, thresholds wait. Earth's climate during these middles often hovers near such thresholds. Slight changes in ocean circulation can cool entire continents. Small shifts in atmospheric composition can amplify warming or cooling far beyond their initial cause. The planet does not seek equilibrium, it circles it. This circling creates variability, seasons, cycles, oscillations that feel repetitive but never truly repeat. Ice advances and retreats, forests expand and contract, deserts bloom briefly then fade. Life responds by becoming flexible. Flexibility is the currency of the middle. Species that can tolerate a range of conditions survive longer than specialists. Ecosystems with redundancy persist better than those built on a single dominant form. Diversity becomes a buffer against collapse. This is why life flourishes most during extended middles, not because conditions are perfect, but because they are varied without being overwhelming. The Earth's most productive eras were not the hottest or coldest, not the calmest or most violent. They were periods of moderated instability, enough disturbance to recycle nutrients and open space, but not enough to erase entire systems. In these middles, time feels expansive. Millions of years pass with incremental change, coastlines drift slowly. Mountains erode grain by grain, species shift their ranges subtly, generation by generation. Nothing dramatic seems to be happening, and yet everything is, because these middles are when pressure accumulates. Carbon builds up slowly in the atmosphere. Ice sheets grow heavier, pressing the crust downward. Sediments pile up, burying organic matter. Tectonic plates inch toward collision. The surface appears stable, but the deep processes never stop. Earth's interior continues to transport heat outward. This heat is not constant. It pulses, waxes, and wanes over geological time. When mantle plumes rise, volcanism increases. When they subside, the surface quiets. These changes ripple outward, influencing climate, sea level, and chemistry. From the perspective of a single organism or even a civilization, the middle feels like permanence. From the perspective of the planet, it is preparation. Every long middle ends, not because it fails, but because accumulation reaches a limit. Carbon dioxide builds until warming accelerates. Ice advances until albedo feedbacks lock the planet into cold. Oxygen rises until it becomes toxic to those unprepared. The middle carries within it the seeds of its own transformation. This is not a flaw, it is inevitability. Earth's history shows that prolonged stability is impossible in a dynamic system driven by energy flows. Gradients flatten then reform elsewhere. The planet is constantly redistributing imbalance. When imbalance becomes too concentrated, catastrophe expresses itself. The middle gives way to transition, and then often to collapse, but collapse is not uniform. It unfolds unevenly across space and time. While one region suffers drought, another floods. While one ecosystem collapses, another expands. While one lineage vanishes, another diversifies. The planet never changes everywhere at once. This patchwork of change is what allows life to persist even during severe disruptions. Refugia exist, places where conditions remain tolerable while the broader system shifts. During ice ages, life survived near the equator and beneath ice-covered oceans. During warming events, life retreated toward poles and depths. During extinctions, small populations lingered in marginal habitats. The middle is never truly global. It is a mosaic. This mosaic quality applies not only to biology but to geology and climate as well. While continents drift, their effects are asymmetric. One region uplifts while another subsides. One ocean warms while another cools. The Earth distributes change unevenly. This unevenness is crucial. It prevents total synchronization. Total synchronization would mean total collapse. By maintaining regional differences, the planet preserves options. This is one of the quiet mechanisms through which Earth avoids complete sterility, even during severe catastrophes. The middle is where these mechanisms operate most effectively. It is where the planet is neither too rigid nor too chaotic, but the middle is not eternal. Eventually, pressures align, thresholds converge, and the system shifts. This shift may take thousands of years or millions, but once it begins, it accelerates. The Earth has crossed such inflection points repeatedly. The onset of snowball Earth, the Great Oxidation, the Permian collapse, the end of the dinosaurs, each marked the end of a long middle. Each was followed by a reconfiguration that created a new middle with different dominant forms, different vulnerabilities, different possibilities. From this perspective, the present moment is also a middle. It is not the beginning of Earth's story. It is not the end. It is a long interval of accumulated change, some of which is only now becoming visible. Human civilization arose during a particularly narrow middle, a warm, stable climate window with predictable seasons and abundant freshwater. That window allowed agriculture, cities, and complex social systems to emerge. But the very success of those systems altered the conditions that supported them. Energy extraction increased, atmospheric composition shifted, land surfaces changed reflectivity, biogeochemical cycles accelerated. These changes accumulated quietly for centuries. Now some thresholds are beginning to respond. This does not mean catastrophe is imminent in a single moment. It means the middle is evolving. The Earth is moving toward another transition. Transitions are not inherently destructive. They are disruptive, they redistribute, they test adaptability. Some systems will fail, others will persist in altered form. This has always been the pattern. The danger lies not in transition itself, but in assuming the middle will last unchanged. Assumption creates fragility. Earth's history shows that resilience comes from anticipating change, not denying it. Life that clings too tightly to a single set of conditions eventually finds itself exposed when those conditions shift. Life that tolerates variation survives longer. The middle favors those who do not mistake stability for permanence. This lesson is written into stone. Every sedimentary layer records a former present that once seemed enduring. Every fossilized forest marks a climate that no longer exists. Every ancient shoreline stands far from water. They were middles too. They ended, yet their ending did not end the story. It advanced it. The Earth's long middles also shape perception. When change is slow, it becomes invisible. Generations pass without noticing drift. What was once rare becomes normal. What was once normal becomes memory. This gradualism dulls alarm. By the time thresholds are crossed, the conditions that caused them may feel distant, abstract, or unavoidable. This is why catastrophe often feels sudden, not because it arrives without cause, but because its causes unfold during middles that feel unremarkable. The planet does not shout when pressure builds. It whispers, ice thickens by millimeters. Carbon accumulates by parts per million. Stress loads faults by fractions of a millimeter per year. The scale is deceptive. The effect is not. Earth's middles are where responsibility becomes ambiguous. When catastrophe finally expresses itself, blame feels misplaced. The forces involved operated for far longer than any single decision or generation. This is why planetary change defies simple narratives. There is no singular villain. There is only process. Understanding this does not absolve agency, it contextualizes it. Humans are not separate from Earth's middles, they are participants within them. Their actions contribute to accumulation just as volcanic eruptions and microbial metabolisms once did. The planet does not differentiate between intentional and unintentional causes. It responds to totals, energy in, energy out, composition altered, gradients adjusted. The middle responds accordingly. From deep time's perspective, the present is neither uniquely dangerous nor uniquely safe. It is uniquely complex. Never before has a single species altered so many planetary systems simultaneously: atmosphere, hydrology, biosphere, sedimentation, and energy flow. This concentration of influence is itself unprecedented. Whether it leads to collapse, adaptation, or something entirely new remains uncertain. But uncertainty has always defined the middle. Earth's history is not a cautionary tale in the moral sense. It is a descriptive one. It shows what happens when systems exceed their adaptive capacity. It shows that collapse is often followed by innovation. It shows that complexity can recover but never identically. The middle does not promise continuity. It offers opportunity. Opportunity to adjust before thresholds harden into new regimes. Opportunity to reduce fragility by increasing flexibility. Opportunity to recognize that stability is a phase, not a destination. Earth does not reward denial, it responds to reality. The long middle of becoming is where this response unfolds most subtly. It is where change gathers itself before expressing outwardly. It is where futures are decided quietly without spectacle. And it is where awareness matters most, not because awareness can stop change, but because it can influence how systems navigate it. The Earth will move forward regardless. The middle will end, another configuration will follow. What that configuration looks like depends not on desire, but on interaction between processes. This is not the final chapter. It is not even a turning point yet. It is the deep, extended middle where pressure accumulates, possibilities branch, and outcomes remain open. There is a particular heaviness to deep time that is difficult to describe without metaphor. It is not urgency. It is not suspense. It is not anticipation. It is weight, the kind of weight that comes from accumulation, layer upon layer of consequence pressing downward, not crushing but compacting. Earth carries this weight everywhere, in its crust, in its atmosphere, in the chemistry of its oceans, in the inherited structure of its living systems. Nothing on this planet exists without that pressure behind it. The present moment is shaped by everything that preceded it, not just by dramatic catastrophes, but by countless small continuities that persisted long enough to matter. Tiny shifts that compounded, minor imbalances that never fully resolved, quiet survivals that altered what was possible later. This is how the Earth moves most of the time, not by leaping forward but by leaning into change slowly until the slope becomes steep enough that movement accelerates on its own. From within the present, this leaning is hard to feel. Human senses evolved to detect immediate threats, not trends unfolding over centuries or millennia. The mind is drawn to sudden breaks, the earthquake, the eruption, the flood, because they align with instinct. But Earth's most consequential movements often unfold beneath perception. The slow rise of atmospheric oxygen was invisible to early life until it crossed a threshold that made survival impossible. The gradual cooling that led to global glaciation felt insignificant until ice reached the tropics. The incremental warming that preceded mass extinctions felt tolerable until it became lethal. Catastrophe rarely announces itself early. It waits. This waiting gives the illusion of control. During long middles, when systems appear stable, there is a temptation to believe that the rules have changed, that Earth has entered a permanent phase of balance, that the violent past is behind it. This belief has emerged repeatedly throughout history. Each time it has been proven temporary. Because the Earth does not settle into equilibrium, it oscillates around it. The forces driving this oscillation are vast and impersonal. Solar radiation varies, orbital parameters shift, plate tectonics rearrange geography, biogeochemical cycles amplify or dampen feedbacks. None of these processes ask permission, they proceed. The weight of time ensures that even slight imbalances matter. A few extra watts of energy retained by the atmosphere change circulation patterns. Slightly altered currents redistribute heat differently. Small changes in ice cover modify reflectivity. Each adjustment feeds into the next. The system responds holistically. This is why Earth's history cannot be understood by isolating single causes. Every catastrophe emerges from convergence, multiple processes aligning long enough to push the system past a threshold. The Great Dying was not caused by volcanism alone, but by volcanism interacting with ocean chemistry, atmospheric feedbacks, and biological vulnerability. The extinction of the dinosaurs was not caused solely by an asteroid, but by the ecosystem stress already present at the time of impact. Catastrophe is rarely singular, it is cumulative. This cumulative nature gives Earth's history a particular texture. Events are not evenly spaced, they cluster. Periods of relative calm are punctuated by intervals of intense change. After each major reorganization, the system resets with new parameters. The Earth forgets some things, but it remembers structure. After mass extinctions, diversity recovers, but food webs are simplified. Dominant strategies change. Evolution explores different paths. The new world carries the imprint of the catastrophe that shaped it. In this way, every present moment is an archive, the distribution of species. The chemistry of soils, the composition of the atmosphere, all are records of past pressures. Nothing is neutral. This is especially true of life. Life is often described as resilient, and it is, but resilience does not mean invulnerability. It means persistence through change by transformation, not by stasis. When conditions shift, life does not fight to preserve what it was, it becomes something else. This transformation can be slow or fast, subtle or dramatic, but it is unavoidable. Species that resist change too rigidly disappear. Those that tolerate variation persist. The Earth does not select for perfection, it selects for adaptability. This principle applies equally to physical systems. Rivers that resist change eventually flood catastrophically. Rivers that meander gradually release energy and persist longer. Landscapes that absorb stress slowly endure. Those that lock it in fail abruptly. Flexibility is survival at every scale. Earth's long history is a lesson in distributed resilience. No single system carries all the burden. Energy flows through many pathways. When one pathway fails, others compensate until compensation is no longer possible. The breaking point is never arbitrary. It arrives when capacity is exceeded. From this perspective, catastrophe is not an anomaly. It is the moment when accumulated stress finds expression. The release can be violent or quiet. An earthquake releases stress in seconds. A climate shift releases stress over centuries. Both are catastrophes. One is immediate, the other is delayed. The Earth does not distinguish between them. It responds to imbalance. This indifference to timescale is what makes planetary change so difficult to anticipate. Human planning operates on years and decades. Earth operates on millennia and millions of years. When these scales intersect, misunderstandings arise. What seems gradual to a planet feels abrupt to a civilization. What seems negligible to a lifetime becomes decisive over generations. This mismatch creates vulnerability. The Earth's middles are dangerous not because they are unstable, but because they invite complacency. They allow systems to grow dependent on specific conditions. They reward optimization over robustness. Optimization is efficient. Robustness is durable. Earth favors durability. Systems that over-optimize for narrow conditions thrive briefly, then collapse when those conditions change. Systems that maintain redundancy and diversity endure longer, even if they are less efficient. Nature is inefficient on purpose. That inefficiency is what absorbs shock. Forests contain multiple species performing similar roles. Food webs have overlapping pathways. Oceans distribute heat through multiple currents. This redundancy prevents single points of failure. When redundancy erodes, catastrophe becomes more likely. This erosion can happen slowly. Diversity declines gradually. Habitats fragment incrementally. Systems appear functional until they are pushed slightly beyond their reduced capacity. Then failure cascades. This pattern appears repeatedly in Earth's past. Coral reefs flourish until temperature or acidity crosses a threshold. Then bleaching spreads rapidly. Forests persist until drought weakens them. Then fire consumes them. Ice sheets remain stable until warming thins them. Then collapse accelerates. The middle masks fragility. The Earth's weight of time ensures that fragility is eventually tested. This is not punishment, it is mechanics. Understanding this reframes the role of catastrophe. It is not the enemy of stability, it is the measure of it. Catastrophe reveals which structures were resilient and which were brittle. After each major disruption, the Earth emerges altered but functional. The planet does not break permanently. It reorganizes around new constraints. This reorganization is not guided by intention. It is guided by physics. Life reappears where conditions allow. Complexity increases where energy gradients support it. Systems simplify where constraints tighten. Nothing is wasted. Even collapse feeds continuity. This does not make catastrophe gentle. It makes it necessary. The Earth's surface today is the product of countless such necessities. Mountains exist because plates collided. Plains exist because mountains eroded. Soils exist because life and rock interacted under changing climates. Every fertile landscape is built on destruction. Every stable ecosystem rests on past instability. This truth is uncomfortable because it undermines the desire for permanence. But permanence has never existed on this planet, only persistence through change. When the Earth seems calm, it is because the rates of change are slow relative to perception. But slow does not mean small. Slow changes accumulate more power. The slow accumulation of ice can reshape continents. The slow accumulation of carbon can alter global climate. The slow accumulation of stress can level cities. The Earth is patient. It waits until the arithmetic resolves. This patience is not wisdom. It is inevitability. In deep time, cause and effect are separated by spans that dwarf intention. Actions taken under one climate regime echo under another. Decisions made under abundance shape scarcity centuries later. This delayed feedback is one of Earth's defining characteristics. It ensures that the consequences of change are rarely immediate. This is why catastrophe often feels undeserved. It arrives long after the conditions that caused it were established. This delay challenges moral narratives. The Earth does not deliver consequences on human schedules. It delivers them on its own. Understanding this does not grant control. It grants humility. The planet's history shows that no system, no matter how successful, escapes eventual transformation. Dominance is temporary, balance is provisional, stability is borrowed time. Yet within this impermanence, something remarkable persists. Complexity returns, life adapts, new middles emerge. After each collapse, the Earth does not revert to simplicity forever. It explores again, often reaching greater complexity than before. The biosphere after the Permian extinction eventually surpassed its previous diversity. Mammals after the dinosaurs diversified into forms never before seen. Forests returned after ice retreated. This suggests that while catastrophe simplifies systems, it does not eliminate the capacity for complexity. The capacity remains embedded in the planet's structure. As long as energy flows and gradients exist, complexity is possible. The Earth has always preserved this potential. This preservation is not intentional, it is structural. Gravity keeps matter together. Solar energy drives chemistry. Water enables interaction. These conditions persist across catastrophes. As long as they do, life can return, awareness can return, something new can arise. The Earth's long middle of becoming is therefore not a waiting room for the end. It is the arena where potential accumulates. The present moment, like all presents before it, sits within this arena. It is neither uniquely doomed nor uniquely privileged. It is simply another configuration, another balance point. Another middle carrying the weight of past catastrophes and the seeds of future ones. This does not diminish the significance of now. It deepens it. To exist in a middle is to participate in transition, whether consciously or not. Every action, every change feeds into accumulation. The Earth does not need guidance, but it records influence. Catastrophe has no single face. What it looks like depends entirely on where one stands, how long one watches, and what one remembers. From the surface of the Earth, catastrophe often appears sudden, an interruption, a rupture in the expected flow of things. A river floods, the ground shakes, fire sweeps through a forest. Life divides itself cleanly into before and after, but from above, from farther away, or from deeper in time, that clean division dissolves. The flood becomes part of a long hydrological cycle. The earthquake becomes a momentary release in a centuries-long accumulation of stress. The fire becomes a nutrient pulse, clearing space for renewal. The same event wears many meanings at once. This is the paradox at the heart of catastrophe. It is always real, always consequential, and yet never complete on its own. Its significance expands or contracts with scale. At the scale of a human life, catastrophe can feel absolute. Homes lost, loved ones gone, landscapes unrecognizable. The mind seeks narrative closure, an explanation, a cause, a lesson, because meaning feels necessary for survival. At the scale of ecosystems, catastrophe is disruptive but rarely final. Populations collapse but others expand. Energy flows reroute, niches open, the system rebalances, though not without loss. At the scale of the planet, catastrophe is simply motion, energy moving from one configuration to another. And at the scale of the universe, catastrophe is background noise. Stars explode constantly, galaxies collide, worlds are born and destroyed without pause. The universe does not slow down to acknowledge any single event. This layering of meaning creates tension. A catastrophe that ends a civilization may barely register in geological records. A mass extinction that reshapes the biosphere may feel imperceptible in any single moment. A planetary transformation may be invisible without instruments and models. The Earth exists across all of these scales simultaneously. This is why understanding catastrophe is so difficult. It requires holding multiple truths at once. That loss is real and devastating. That change is inevitable and ongoing. That endings are not final in the larger context. The Earth does not resolve these truths, it contains them. When one studies deep time, it becomes clear that catastrophe is not a deviation from Earth's normal behavior. It is normal behavior. The planet's surface is dynamic because energy is constantly moving through it. Solar radiation heats unevenly. Internal heat escapes unevenly. Gravity pulls unevenly. These unevennesses generate motion. Motion generates stress. Stress seeks release. Release is catastrophe. This chain never breaks. What changes is how that release manifests. In early Earth history, releases were violent and frequent because gradients were steep and systems were immature. As the planet aged, gradients softened but complexity increased. Catastrophes became less frequent but more layered in their effects. Life added feedback loops. Oxygen altered chemistry. Plants altered erosion. Animals altered nutrient cycles. Each addition increased both resilience and vulnerability. Resilience because systems gained redundancy. Vulnerability because systems gain dependencies. This duality is crucial. A lifeless planet can endure extreme conditions without consequence because there is nothing to lose. A living planet must navigate narrow ranges to maintain complexity. The more complex the system, the narrower its tolerances. This does not make complexity a mistake, it makes it delicate. Earth's history is the story of a planet repeatedly flirting with the edge of its own tolerances, sometimes crossing them, sometimes pulling back, always changing as a result. The biosphere has been wiped nearly clean at least once. It has been drastically reduced several times. Each time it returned not because it was guaranteed to, but because conditions still allowed it. This allowance is the quiet hero of Earth's story. The planet has never promised life continuity. It has only offered opportunity. When opportunity closes, life fades. When it reopens, life returns. This ebb and flow is not moral, it is structural. From this perspective, catastrophe is neither failure nor success. It is transition. Transitions are uncomfortable because they break familiarity. They dissolve expectations. They force adaptation under pressure. But transitions are also where novelty emerges. Every major innovation in Earth's history followed catastrophe. Photosynthesis rose after environmental stress. Complex cells emerged after oxygen reshaped chemistry. Multicellularity expanded after global freezes. Large animals diversified after mass extinctions. Catastrophe clears the board unevenly, creating asymmetries that evolution exploits. This is not optimization, it is exploration. The Earth explores possibility through disruption. This exploration has no endpoint. It does not aim toward intelligence, complexity, or beauty. Those are byproducts, not goals. The planet does not care whether the future contains forests or microbes, cities or silence. It responds to gradients. When gradients support complexity, complexity appears. When they do not, complexity fades. Understanding this does not require surrendering hope, it requires redefining it. Hope on planetary scales is not about preservation of form, it is about persistence of process. As long as energy flows and matter interacts, something will happen. Whether that something resembles what came before is irrelevant to the planet. It matters only to those who remember. Memory is the fragile layer atop Earth's processes. Geology remembers mechanically. Chemistry remembers compositionally. Life remembers biologically. Consciousness remembers narratively. Each form of memory operates differently. Geological memory is slow and durable. Layers persist for billions of years. Faults retain scars of ancient movements. Craters remain long after their causes vanish. Chemical memory is diffuse. The atmosphere carries signatures of past metabolisms. Oceans record changes in isotopes and acidity. These memories fade slowly as systems mix. Biological memory is selective. Genes preserve successful adaptations. Lineages carry information forward but discard what no longer fits. Narrative memory is brief. Stories last only as long as minds do. Catastrophe interacts with each layer differently. An asteroid impact leaves a geological scar, alters chemistry globally, wipes out biological lineages, and reshapes narratives instantly. The deeper the memory layer, the longer catastrophe's imprint endures. This layering means that no catastrophe is ever fully erased. It persists somewhere. Even events that feel forgotten live on as conditions shaping the present. The oxygen you breathe is a residue of ancient microbial catastrophe. The coal and oil beneath the ground are residues of ancient forests buried by disruption. The continents' shapes reflect collisions and rifts long vanished. The earth is an archive of disasters transformed into foundations. This reframing changes how endings appear. An ending is not removal, it is integration. What ends becomes part of what follows. Even extinction is not pure loss, it is redistribution. The matter that once formed bodies returns to soil, water, and air. The energy stored in tissues dissipates as heat. The genetic information vanishes, but the ecological space remains. Something else fills it. This does not lessen the tragedy experienced within that moment. It contextualizes it. Context does not heal loss, but it alters interpretation. The earth does not privilege interpretation. It records outcomes. When catastrophe strikes, the planet does not ask whether it is deserved, avoidable, or meaningful. It adjusts. This adjustment can take many forms. Climate regimes shift, sea levels rise or fall. Ecosystems reorganize, landscapes erode or uplift. Sometimes adjustment overshoots, triggering further instability. Sometimes it settles into a new balance. The earth does not aim for optimal states. It aims for states that dissipate energy efficiently. This principle, energy dissipation, underlies everything. Rivers flow downhill because gravity demands it. Storms form because heat must move from warm to cool. Life metabolizes because chemical gradients allow it. Catastrophe is often the most efficient way to dissipate accumulated energy. An earthquake releases centuries of tectonic stress in seconds. A wildfire releases decades of stored biomass energy in hours. A mass extinction releases ecological constraints accumulated over millions of years. Efficiency is not gentle, but it is effective. The earth is efficient. This efficiency ensures that nothing remains locked indefinitely. Stress always finds a pathway. Understanding this makes the long interval between catastrophes feel less secure. and it should. The middle is not safe. It is simply delayed, but delayed does not mean doomed. It means dynamic. Earth's middles are where choices matter, not because they stop catastrophe, but because they shape how it unfolds. The configuration of systems at the moment of transition determines what survives. Diversity increases survival options. Connectivity spreads risk. Rigidity concentrates failure. These principles apply across scales. A brittle ecosystem collapses faster than a diverse one. A rigid civilization fails harder than a flexible one. A locked climate system responds more violently than a buffered one. The Earth's history demonstrates this repeatedly. When diversity is high, recovery is faster. When redundancy exists, collapse is partial. When systems are over-specialized, catastrophe is absolute. This is not philosophy. It is patterns observed in forests, reefs, ice sheets, and societies. The Earth does not protect complexity for its own sake, but complexity that distributes stress tends to persist longer. This persistence creates the illusion of stability. The illusion lasts until it doesn't. At that point, catastrophe feels shocking, even though it has been building quietly. The silence before catastrophe is deceptive. It is not absence of motion. It is motion below perception, pressure accumulating, heat building, chemical balances shifting. The Earth is never still. Silence is simply change without sound. When catastrophe finally speaks, it speaks loudly because it compresses long preparation into short expression. But the expression is only the surface. The preparation is the story. Deep time teaches that to understand catastrophe, one must listen to preparation, not just explosion. Preparation happens everywhere, in melting ice, in warming seas, in thinning forests, in shifting currents. These are not disasters yet, they are indicators. The Earth whispers long before it shouts. Whether those whispers are heard or ignored does not change the outcome. It only changes readiness. The planet does not wait for understanding, it moves. And in moving, it creates futures that feel sudden only because their origins were spread across centuries. This is the strange mercy of deep time. It gives warnings that are long but quiet, and when change finally arrives, it feels inevitable. Because it was, the Earth does not rush, but it does not stop. At the very end of the story, there is no explosion. There is no final catastrophe that announces itself as the last. There is only continuity. The Earth does not conclude the way stories do. It does not resolve its tension or close its arcs. Simply keeps moving, changing form, exchanging energy, transforming matter, long after familiar reference points have dissolved. What we call the end is only the limit of our ability to follow. From the planet's perspective, there has never been a beginning that was not also an ending, and never an ending that was not also a beginning reshaped. The molten earth ended the dust that formed it. The frozen earth ended the warmth that preceded it. The oxygenated earth ended worlds that could not breathe. The burning earth ended forests to make soil. The silent earth will one day end voices, not as punishment, but as transition. Nothing was taken personally. Nothing was spared deliberately. Everything was allowed to become something else. This is the quiet truth written beneath every catastrophe. That change is not a disruption of order, it is the order. When we look back across the entire span of Earth's existence, from chaos to crust, from ocean to organism, from extinction to awareness, one pattern appears again and again. The planet does not preserve states, it preserves motion. Stability appears briefly when opposing forces balance, then that balance shifts, then the system responds, over and over endlessly, without memory of comfort or fear. This is why the Earth feels ancient. Not because it is old in years alone, but because it has endured so many versions of itself that no single one defines it. The world of fire was real. The world of ice was real. The The world of forests was real. The world of silence will be real. None of them were permanent. All of them mattered. The temptation, especially for a thinking species, is to believe that awareness changes the rules. That understanding catastrophe somehow places us outside of it. That foresight grants exemption. But Earth's history offers no evidence for exemption. It offers only participation. Awareness does not remove us from the system. It embeds us more deeply within it. For the first time, a species can trace catastrophe backward through time and forward into possibility. It can recognize patterns that once unfolded blindly. It can see that the present moment is neither secure nor doomed but transitional. This awareness is rare, and it is fragile. Whether it persists is not guaranteed. But its existence, even briefly, is remarkable, because awareness allows something new within catastrophe. It allows reflection, and reflection allows choice. Not the choice to stop Earth's motion that has never been possible, but the choice of how to move within it. The planet does not ask us to save it. It does not require guardianship. It will continue with or without us. What awareness offers is not control over catastrophe, but relationship to it. The ability to see change not only as loss, but as signal. The ability to reduce unnecessary fragility. The ability to value flexibility over permanence. These abilities do not cancel catastrophe, they shape aftermath. Earth has always judged survival the same way, not by strength, not by dominance, but by adaptability. The species that endured longest were not those that ruled hardest, but those that tolerated uncertainty. The ecosystems that persisted were not those frozen in perfection, but those open to disturbance. Rigid systems break, flexible systems bend. This truth applies everywhere, to forests and reefs, to climates and continents, to societies and ideas. Catastrophe does not destroy everything. It destroys what cannot move. The final lesson of Earth's long history is not despair, it is humility. The recognition that nothing we know is fixed and nothing we value is guaranteed, but that impermanence does not equal meaninglessness. In fact, it may be the source of meaning, because what exists briefly must matter now, because what can change must be tended with care, because what will end can still be witnessed. The Earth does not promise safety, but it has always offered wonder, a planet that could freeze solid and then bloom with life. A world that could nearly erase itself and then recover with greater complexity. A system that could give rise to beings capable of asking where catastrophe comes from and what follows it. That alone is extraordinary. And so the story does not end with fire or ice or silence. It ends here, in the present moment, with awareness listening to deep time, realizing that catastrophe is not the opposite of life, but the rhythm that shaped it. The Earth will continue. That much is certain. What forms will walk upon it next, or whether anything will at all, remains open. And that openness, that uncertainty, is not failure, it is possibility. If you've stayed with this journey through deep time, through fire and ice, through endings and renewals, thank you for listening. If you found this story calming, meaningful, or worth returning to, please subscribe to the channel so you can continue exploring the quiet history of our world together. Leave a comment below and tell us where you're watching from, which part of the Earth you're listening from tonight, and as always, rest well. The planet has carried far greater catastrophes than this moment, and it is still here.